Yo, what's up? Good morning. Still a little bit sick, but let's try this anyway. So we're currently working on reflection. It's mainly going to be used for, or it's initially only going to be used for the water, but I'm pretty sure we're going to find a lot of useful cases for this. And we're doing screen space reflections. And I'm trying to implement it much like these guys did it. Although there has been some coordinate system mismatches and stuff. So we're not quite there just yet. But hopefully we will get there today. So we have implemented it fully and we have started going through it. Take a look at, like, this is a point where this could be wrong, or this is a point where this could be wrong. Let's double check it. And we have double checked all this, but I'm still having a little bit of a, I think, ray start point, ray end point, and ray direction here. I'm still not fully okay with this because we have, the thing is that I think when they did this in OpenGL or whatever they used, like they work with different coordinate systems or coordinate systems that are structured in a different way. So for instance, in our case, when we work in view space, you move away from the camera in the negative Z direction. So the camera looks in the negative Z direction. And this screws it up a little bit. So let's say that most of the algorithm is relative to view space. And their view space is along the positive Z axis. That means that we have a lot of mismatch. So I just need to double check that today. And what bothers me is that Q0 and Q1 is relative to view space, but non-homogeneous or something like that, because what we do here is that we divide with the W screen space position component. So yeah, still a lot of question marks. Hopefully we can clear some things out today. Hopefully everything, but yeah, I'm just gonna blame the cold I'm having and do my best nonetheless. So let's see. So we have two options here. We could try and rework our start point, direction, and end point in such a way that we are working with positive Z values, or we could change the comparison here to take into account that we're going in the negative direction. Yo, what's up, Mimi? It goes pretty good. Just started today, and I have high hopes, but I might be defeated in a couple of hours. We'll see. So we could either make this work in positive Z, or we make everything else work in positive Z. And here we flip one already. But let's take a look here. So start point and direction. So we have this comparison we need to take into account. Creation of end point. This we don't want to change, because here we rely on unity functions, and unity function relies on this one to be in the negative Z direction for it to transform to the other space accordingly. So here we don't want to change it. This one, big question mark. So if we don't change this one, So we don't change this one. Do we want to change this one? I don't know. Honestly, this one is still a big question mark for me. If we take a look at Q0 and Q1, what we do for that one is, or what we use it for, is to calculate a new Z-ray max. That's all we use it for. But this one, on the other hand, is very important. So it has to be correct. I'm wondering if let's do this. Okay, so we change it to this, and then we want to fix this one. We want to change this comparison now. So I'm wondering if we want to do, we take negative Z and then I wonder, I think we want to we should want to change this one as well, I think. Which gives us this, which is wrong. So if we move away from the camera, this is how it should be. Okay, good. And then we do ray length, and then we want negative here as well. Or do we? Let's see here. Or I guess we could just do negative here. Mimi finally joined the Discord server. Welcome. It's a bit handy actually. I guess it's, if you have any question you can just post it, but mostly it's used to when I release videos or start streaming, I post there. So I think we want to work in a negative, we want to work with the space in the same way as Unity does. So we just want to change these two pretty much. Yo, good morning, Harukanan. This should be, so if this one is positive, we get negative. I'm pretty sure we should do like this. And ray length. Okay, so if this one is I'm not so sure we want to do it like this. So basically we want to clip the rail length here so we don't go behind this one. Shouldn't it just be... Yeah. Let's print this again. Okay, this is good. This I like. Let's do... But it's being pure black that I don't like. Okay. Shouldn't be a precedence issue. No, it shouldn't. So how come this doesn't yield the correct result? So this one is 0.1, I think. This is negative. We don't change this. No, we don't. We change it so that we just flip it, so we fake it so that we see in the positive Z direction. We need to flip this as well, but yeah. Oh, of course. Yeah, and this is wrong as well. Would probably like it to be the opposite way. We could do this as well. Let's double check these. once again. So why, what is it I'm misunderstanding with this? We want to flip this, we want to flip this. And then we should be working in positive. I haven't changed Ray Max. Where do we have it? No, and let's take this one. It's white, almost black, or gray. Unity camera, negative. Okay, let's see. Unity view space. Let's make sure I have understood everything. Would like it in text, please. negative Z should be front, so what the fuck? View space, eye space, okay, what the hell? Exactly. Okay. Okay. Okay, so given the fact that in view space we're watching in the negative Z direction, what makes this wrong? I'm honestly... So this, for instance, when we have a ray that should reflect right back at the camera, here we get false. For this one, we should be getting this result but inverted. Extremely tiresome. Unless... Unless view direction world space. Could it be? Could it be that we want to do this if we want to have this one in? don't know. We want to do it like this, right? Or fuck, do we? Minus this one. Yeah, let's go back to the basics. This, the result from this, let's see, yeah, makes this make sense. Because if we invert these, we get the correct result, right? Yeah. So if we want to make this make sense, we do negative plus, and then this. And then if we take a look at this, what do we want to do? We want to do okay, so if this one is, yeah, let's say that it's positive. Let me bring up, let's do some drawings here. So if we have something like this near clip plane, this is not, let's put the plane there. We have an array like this. In view space, this one has a set of, let's say, 2, and we have array length of what do we have? Let's say 5. And we want to change this one so we just reach this one. So that would be, if this one is 2, we do I'm wondering, yeah, we want to keep rate of change. Do we? Ray length. Yeah, we do. So we would like to take if we have 2 here, currently we do so -2, which would put us here, and then we do minus this one, which is wrong. Okay, so if we want to get this correct as well, we should be doing, fuck should we do? We would pretty much like to take we want to find this point, then calculate this length. And how do we do that in an easy way? We do what do we have? We have Ray's start point, which is this one. We have previous ray length and ray direction. We have the ray length that takes us beyond the point we want to be at. Honestly, if we would be working in a view space where we look in the positive Z direction, how would this make sense? We would be this would be negative. This would also be negative though. I don't know about this. But yeah, wouldn't we just like to figure out how far, and maybe that's what we're doing, how far beyond this one are we? How far beyond are we? So we calculate this length and then we just subtract this length from this one. Shouldn't that be what we should be doing here? Isn't it as straightforward as that? EFO, thank you for the follow, appreciate it. Or am I oversimplifying it? Am I losing some information by doing this? So let's say we get 5, but we are... what are we? We calculate this length, but how would we go about doing that? No, I think we have that length. We only care about... No. Okay. We don't have this length. We don't have this length, right? Yeah. But what we could do is, what do we do with ray length actually? Ray length, we only calculate... Do we only calculate endpoint using this one? That's all we do, right? This one. So what the fuck, let's simplify it a bit. Ray start point, ray direction, ray end point. And then we need to check if we need to shorten this one. And we could do it by doing... We check the Z on this one if... Fuck, shouldn't this be as easy as this? Return... I want to try this, I want to print it. If ray endpoint Z... Negative, of course. If it's less than projection params Y, give 1, otherwise 0. Undeclared identity. Yes, we want to calculate this one. Looks to be alright. So we pretty much only want to figure out... So here we do if ray endpoint vs is .z negative is less than projection params.y. If this is true, then we want to cut it off, basically. And we want to cut it off in such a way that we just get to this point. And I think we should be able to do it by... Shouldn't we be able to do lerp? Let's call this A, B. We lerp between A, B, and our T is inv lerp between A dot Z clip plane, so near clip, no. AC, B, C, and near clip point, right? So if this one is 2, what the hell is this one? -3 maybe. So inverse lerp between -3 and 2. This one. So this gives us a value between 0 and 1. There's something like that. Should give us the endpoint, right? So is equal to lerp ray start point vs ray end point vs inverse lerp ray start point vs dot z negative. Do we care about negative here? I don't know. Ray endpoint vs dot z fuck, shouldn't we be able to do this? Maybe just a more costly way to do this. So basically we do inverse lerp first of all. So how far along this ray are we to be at a value of z? Yeah, should work. Yeah, I think so. Might want to saturate. And let's see. Hit pixel. Oh, this is so fucked. I don't even know where to begin. And honestly, I just have to try. What kind of result do we get if we just skip this? So the reason we want to do this basically is as soon as we start marching on positions on the ray that is behind the camera, it's pretty much useless calculations we do. We're not going to find anything of interest there because we don't have anything. We don't know how behind the camera looks, so we just want to shorten this ray so that we don't do a set of a set of calculations that is eventually not going to end up at anything. But we can see here that this one is not the cause. It's not cause for the shit show we're seeing here. Okay, that's good to know. Okay, I'm pretty sure this is being calculated the correct way now. That part of it, at least. Can we simplify this in such a way that we just use P0 and just make it work with that one, not taking into account whatever this is. I want to see, so if we do what the hell, P0 0.y. Okay, that's good. Now I want to see if we switch this one and this one to 1. Fuck, is this actually the endpoints we have yellow? What is that? 1, 1? So what do we have here? 0, 0. Is that the case? Mm. Yo, Zapuka, that sounds nice. Enjoy it. I'm wondering here, in most cases, or pretty much always, we're gonna get a ray endpoint that is way outside of the screen. Shouldn't we want to quit? Based on that. Yeah, okay, if said scene if hit pixel here is outside of the screen, I don't know if... Nah, this is not gonna be 0 then. It's gonna be... We're just gonna... It depends on if this is repeat or clamp, I suppose. But I wonder if we could do... Puka, yeah, I tried to get off energy drinks with some caffeine pills, but somehow they had no effect. You don't know how relatable that is to me right now. Caffeine pills, though, I don't know. Feels like probably the worst possible way to ingest your caffeine, right? Calvino, second cup of coffee at the moment. Let's go. Ah, nice. Okay, I'm torn between trying to make this solution work or go off script a tiny bit, because I think we would be able to do. Okay, so let's put it this way. There's a few sections here which are still big unknowns to me. I don't know exactly why they do them or exactly what they does. Which means, and because of all the coordinate system mismatches we get going on, it's gonna be hella hard to understand it. Unfortunately, the write-up here doesn't go that much into detail, and I'm gonna have to do some searching to get the actual paper for it if it's still available. Which would lead to a lot of guesswork. Or we could pivot a tiny bit. We can take what we know here and implement a little bit less optimal ray march, but that will hopefully yield the correct result at least. So pretty much we calculate a ray in view space. We have already done that. We have the start and end point. We have also clamped the endpoint so that it's within the near clip plane, but that doesn't really matter that much. Instead, we would heavily focus on these two. So that gives us a start point in screen space, an end point in screen space, and we can just walk along that ray and compare the depth for each step. Is this depth within the threshold for an intersection? If so, return whatever that pixel has. That would be pretty easy. I guess we would be using thickness then at least. But yeah. And I might try to read up on this and make it work at a later point. Oh, do we have... One sec, I got a call. Be right back, 1 sec. Okay, back. Sorry about that. What the fuck? So let's see. Let's just go off script a tiny bit. See if we can make this work with a simple solution. What have I? Can I get? I just want to try if we can get a good result by just relying on these two, basically. Ray start point SS, ray end point SS. Let's try. Just check so we have the correct points here. Oh yeah, this one. Fuck. Yeah, might not want to do. Okay, beautiful. So we have a ray start point, we have a ray end point. Let's just walk according to that one, and then we want to check. Let's see here, what is the depth? I think we want to compare intersection. We have to define what we would call an intersection, and that would probably be when if we read let's see here. it's pretty much this comparison we want to do. So not really, but something similar. So we want to read a depth value. We have a thickness that we care about. If I don't know about So I wonder if we want, okay, so we have the ray, we have, and then we walk in sections like this. And when we have a section like this, I wonder, do we want to read, would it be sufficient to read the middle point? We take the depth here. If this depth is don't we actually... fuck. Might be out on thin ice here, but if we get a variation in depth, direction, pretty much. So let's say that we start walking through the ray and we notice that for each step we get deeper and deeper into the scene. If we notice that we, for one step, go in the inverted direction, or we get a big enough change, that means we hit something right. But we need to figure out if the difference is big enough for it to actually register as or we could do would be the simplest way, I think. We could also introduce scene normals. And if we hit something that would bring us towards the camera again, we can register it and output it. But yeah. Max depth, min depth. Or yeah. And then we want to calculate step as well, yeah. I don't care about walking in the quickest direction, I don't think. But if we do... I'm still afraid we're gonna get a very sloppy result by this. By doing this. Jagged, to say the least. But yeah, the only thing we're gonna change is pretty much how we estimate the new these depths. That is true. Is that what we're doing here? I think it is. Makes sense. But yeah, going off script, doing it ourselves, make this so much clearer. So basically what we're doing here is we're estimating the depth at each step, but it's still a question mark exactly how it's done. Because yes, we don't want to read texture every time. We actually have this data. Oh, that is true. Fuck, one sec. We might go back to this one. We're gonna go back and forth a bit. Am I jumping the gun here by computing screen pos here? Maybe. Maybe. But yeah, we want we wanted to compute screen pos here because we want This is probably not as straightforward as for them, because we might need to take into account like inverted projection matrix, I think it was. Yeah, this one, projection. Oh, that's true. Shade graph, that's not what I want. Deprecated. Yeah, here we go. Projection params X. We take into account. Yeah. Yes. So we want to do this because we want to take projection params X into account. But it should be as easy as let's do this again. So instead of calculating this like this, we do in fact, we should be able to do this, and then we could do or do we have compute clip pos or something like that? Maybe this is enough. So we compute, we do, let's try it. Mul very interested in this one. Let's do we know that this one is correct, so let's do return ray start point depth. Ooh, okay, that's beautiful. Let's see if we get any, if it looks different if we do Ay. Okay. Get the same gradient, but a little bit different values. Why? What are we missing here? One sec. Okay. Fuck, I'm wondering. Yeah, is it a step between clip and NDC we're missing? Transform world to H clip. I don't think. Do we have this one? Yeah, we might, but we're not in world space. So that's unfortunate. We could switch it back, but that's feels like doesn't really feel that good to do. Yo, what's up, Okapifan? I'm still a little bit sick, but other than that, and I'm slowly going like reflection related insane, but that's okay. Yo, what's up, Diligence? Thank you, Cup. Appreciate it. Hope you're doing all right. All of these different spaces here, I'm getting real tired of them. Yeah, we're multi-streaming to Twitch and YouTube. World to view. Okay, so what happens between this and the vertex and fragment shader? That is the question. Yeah, you're correct that this is shaders. I wonder if the only difference is, it's probably not, and it varies between devices. It wouldn't surprise me, but I wonder if the only difference is times 2 minus 1. But the other way around. Because this one is darker, right? So times 0.5 plus 0.5. That's way too much. Okay, so that's not it. Okay, fun shaders is just focus pocus to me. Yeah, I can relate. Sometimes it feels I understand then. Sometimes it feels like I have no idea what I'm doing. Projection matrix, world to camera matrix. Okay, so here we have a MVP matrix. What do we do? Get the fuck out. Okay, so NDC, projection matrix times view space position, and then divide by W. But oh, whoa. Okay. It might be the case that this one is in either non-linear or linear, and this one is in linear or non-linear. So that might be the problem. So what if we do I don't want to do linear eye depth. But do we have linear 0,1 depth? Maybe. That's not it. But Yo, what's up, Ramsey? And this one was already read. But I still don't fully understand Ramsey, I love your devlog videos. You put a lot of effort into making them. It's nice to see effort behind them. Thank you, appreciate it. And you are correct, I did. This is honestly quite insane. So, first of all, you have all of these different spaces. I don't know what we're playing around with. World, view, clip, NDC, whatnot. But that's not all. All of them are handled differently per device as well. For some of them we have some nice macros or methods we can include, but not for all. We want to do this a simple way. So what I'm thinking here is that we recreate a ray that will travel through the screen or through the scene. We will walk along this one and we will find an anomaly in the depth value change. If we find that anomaly, we have hit something that should reflect and we end it. What we could do is, or rather what we want to avoid is when we walk along this view space ray, we want to fetch depth values along it, but our ray is linear in view space. So if we have the start depth and the end depth, we actually know at each point what the depth is. So if we could read that one or calculate that one, interpolate that one, instead of reading depth texture each step, that would be way better. And that's what I'm trying to do here. Unfortunately, I can't seem to recreate. So the start point depth we calculate by doing clip space position, or we're getting it from the clip space position, which I thought would be the equivalent of this, but we're getting a little bit of a mismatch here. And this mismatch, I have no idea. It's something with clip space NDC or whatnot. But it's tiresome. Or fuck it, I guess we could do but then again, I wonder how this will screw us up. Okay, if we do this, let's do this as well. Float depth is equal to sample scene depth UV turn depth What the fuck? 1 sec, be right back. Back, sorry about that. I forgot about a thing today, so I might have to cut this stream short. Didn't have that good flow anyway, so yeah, I gotta run. But let's give this another try tomorrow. Thank you so much for watching, everybody, and have a great rest of the day. Peace.